Rectification is the process by which we convert AC into DC. That process we call rectification. So rectification is the process by which alternating current is converted into direct current. So we are converting AC into DC. For most of the electronic circuit, like diode, transistor, they require DC. Low voltage DC is required. They are not working with AC. So in almost all the electronic circuit, DC is needed. Fan, geyser, heater, these all can work with DC. But the main problem with DC is what? We can't transmit. That's why commercially we can't produce DC. Transmission will not be there. Due to that only we are producing commercially. AC is produced in all power station. AC is produced, and that is AC is transmitted only. So in household wiring supply or in the house, we are getting from the pole, that is AC. Battery, DC. From battery, direction is fixed. So in case of DC, what will be? Direction will be fixed. It will start from positive terminal of the battery. It will reach to the negative terminal through the whatever instrument or whatever the appliance we are connecting. But in alternating current, what happens? There is no positive negative sign in the main supply or in the wiring system, because in 1 second 50 times the direction changes in AC. We have done in class 10 also, we have seen. And the device or the circuit which is doing this job we call rectifier. So rectifier is the electronic circuit or the device that changes AC into DC. So that device or the circuit is or device that we call rectifier. So this diode, as we have done in case of diode, PN junction diode, we have seen the graph. In case of forward biasing, the resistance is very less. We have seen the graph. This one was like this, and here it is almost constant and very less. Here this side is microampere. This side was milliampere current. So here slope is very large. That means resistance is very less. Resistance is inverse of the slope. Because it is I versus V graph. So resistance means delta V over delta I. So it is 1 by slope, inverse of the slope. So as this slope is very large, this current is, this angle is nearly 62, nearly 60 degree, more than 60 degree it will come. So this shows the resistance of the diode is very less in case of forward biasing. Whereas here, if you calculate, what is that? Resistance is almost infinity. This R tends to infinity. In this particular region, when it is going like this, then different case. But when there is no avalanche breakdown, no junction breakdown. In that case, resistance is almost infinity. So practically we say the diode does not conduct when it is in reverse biasing situation. When it is in forward biasing situation, its resistance is almost zero, so 100% good conductor it become. Means it behave like good conductor. So this property is used here in rectifier. By rectifier, this diode does not conduct in reverse biasing. So when there will be reverse biasing, when the direction of current changes in alternating current, for one cycle, the diode will be forward biasing, whereas for second cycle or the other half, it will be reverse biasing. So in case of reverse biasing, it will not work, it will not conduct. So we will have only one directional current, and that is direct current. Okay. So this particular property we are using in rectification or constructing the rectifier. So in our syllabus, there are two types of rectifier which we have to see. One we call half wave rectifier, other is full wave rectifier. Bridge rectifier is not in our syllabus. So only these two we have to see. So first is half wave rectifier. So we have to see the circuit diagram, then it's working. Generally, this rectifier, first voltage of AC will be changed according to our desire, according to our need. Suppose we want only 12 volt DC circuit, or suppose in case of mobile charger, we require only 6 volt. So 6 volt DC is required, or maybe 7 or 8 volt DC will be required. Similarly, for other circuit, sometimes we require only 12 volt, sometimes we require only 6 volt. But the power supply which we are getting is of 220 volt. So first we will use the transformer so that voltage is decreased. Because transformer works only in AC, not in DC. No, that was the main reason why we are producing AC. Because we can't transmit at lower voltage. Much loss will be there. So first we require a transformer. The symbol of transformer we are knowing is like this. Suppose we require it. So if this is the primary, this is the source, AC source. Down transformer, maybe step up also some, but generally we require step down only. So this is step down transformer. Now here we we connect one diode. And here is the load. Load means suppose we want to charge the mobile. So mobile is connected here. That is the load meaning. So this is the circuit of half wave rectifier. Very simple circuit. So this we call load resistance or load simply. This is the junction diode, PN junction diode. This is P, this is N. You are knowing this is P, this is N. The triangle represents P type semiconductor, whereas line represents N type semiconductor. So if this side is positive, then it will conduct. When this side becomes negative, means lower voltage, then it will not conduct. Now what will happen? Suppose we apply 12 volt. In case of transformer, what will be? This neutral wire will always be 0 volt. Whereas this live wire will have a voltage of plus minus, suppose just example, 12 volt. Maybe if you require only 6 volt, then plus minus 6 volt. So its voltage will vary from plus 6 to minus 6. That is plus 6 volt, then 0, then minus 6, again 0. So it will keep on like this only. So this symbol suppose like this it is coming. Means graph if you represent like this. So this is 0, this is suppose plus 12, this is minus 12. So voltage versus time graph will come like this, or current versus time graph will also be like this only. This is the graph of AC. Now, suppose at any instant, this is at plus 12 and this is 0. Is it forward biased or reverse biased? This is here plus 12, this is 0. That is, it is at higher potential. So now it is forward biased. So this diode will conduct. That means it will allow current to pass through this. So when it is at higher voltage, we will get current. So current will pass through this. And the direction of current will be in this direction only, from P to N. So it will be coming like this. This will be the direction of current. This current, suppose it is increasing from 0 to 12 and then 12 to 0. Then current will also increase. When it is 0, 0, both 0, 0, current will be 0. When it is increasing towards positive side, the current will also increase, or its voltage will increase. When it is decreasing from 12 to 0, current will decrease. Naturally, voltage will decrease. Now, after some time, what both has come to 0. This is always at 0. Now, after some time, this will also come to 0. Now, what will happen? It will not conduct. Both are at the same potential, so will not get current. For this cycle, this half cycle, we will get the current, and that current will vary. It will not be constant. Now, consider this part. Now, what is happening? It is moving from 0 to minus 12. So when it has come to minus 12, what will be? This is always at 0 only. This side 0. This is minus 12. That means this P has become of less voltage, negative. So P is less than N. So it will not conduct. Means for this particular cycle, we will not get any current. We will get current for this cycle. For this, diode will not conduct. We will not get any current. Again, for this cycle, we will get current. So as only this half wave we are getting current here. So we say half wave is only rectified. So when we get the graph for this one, then what will be? This part will not be there. So like this only we will get. Voltage may change. Suppose in place of 10, it may come 10 volt. Sorry, in place of 12, it may come 10 volt only, or current, whatever it is. So it may change, but nature will be like this only. Yes, is there any confusion? Why we are saying half wave rectifier and how it is done? Which property we are using? That is the property of the junction diode. As we know, the resistance of junction diode is very high when it is reverse biased. This we are talking before avalanche breakdown. Breakdown has not taken place. That current is almost constant. So resistance is infinity. We keep on increasing the voltage, but there is no change in the current. Considerable change is not there. So voltage keep on increasing, but no change in current. That means resistance is almost infinite. Okay, so this diode will conduct only for the positive half cycle of AC. Now this graph is asked. You have to show AC and this half wave rectifier graph. Sometimes it is input and output. Input means what we are giving to the diode and what we are getting from here. That we call input, and here we call output. So input and output graph. For half wave. So this voltage VI, we say, okay, input voltage. Time will be this one. Up and down both should be same. So this is suppose plus V, this is minus V. There will be variation. Sometimes it is like this, it is at EI only, maybe no problem. This is maximum voltage, this is peak voltage, so E naught we are representing. So plus E naught, this is minus E naught. Whatever symbol you use, no problem. This we call positive half cycle, this we call negative half cycle. Time will be same. This is T by 2, this is T, 3 T by 2, 2T, and that will come. This is our input graph, or input voltage versus time graph. Now output, or potential difference across load. Load means what we are connecting. Suppose mobile we have connected in order to get it charged. So that mobile will become load, or a bulb is connected there. The bulb is the load. So whatever the filament resistance will be, that is the load resistance. Now this output graph will be, this peak voltage you can change, no problem. Time will be same. So when this is happening, so this time will remain same. Okay, when it is coming, it must appear that you have understood that timing will be same. Just below that you or adjacent, but timing space should be same. Now what will be here? It will conduct for this half cycle. After that, nothing, zero current. Current or voltage both same graph. This is EI or I also same. If current versus time graph we are plotting, then also same nature. This is output voltage or source load voltage. For this zero, then again it will conduct. So whatever peak you have adjusted, it should remain same everywhere. Okay, so like this. So for positive half cycle, it will conduct. For this negative half cycle, we will not get current. Again, for this one, we will get current. This one, zero. When the diode is reverse biased, we are not getting any current. So as much energy is lost, so practically it is not used. Half wave rectifier, this circuit is never used. Because we will get much fluctuation in current will take place. Now full wave rectifier, that is positive half and negative half, both are converted into DC, that we call full wave rectifier. In case of full wave rectifier, we require a special type of transformer that we call centered tapped transformer. Commonly, what will be output of the transformer will have only 2 wires, but this type of transformer will be having 3 wires. So this special type of transformer we call center tapped transformer. In this type of transformer, what will be, suppose output has got 1000 turns. Then after 500 turns, one wire is soldered there. And that wire is also taken out. That we call centered tap. Exactly in the middle only. If 200 turns are given, then after 100 turns, one wire is taken out. So here, suppose this is the source. Suppose this is like this. Okay, like this it is. So from one wire is connected from here also. If we want output voltage of 6 volt, then this must produce 12 volt, twice of that. If we require 12 volt output, then here potential difference from here to here will be 24 volt. So this type of transformer we call centered tap transformer. This is again input. Now we connect 2 diodes. One will be here, and other one is here. And the load is connected here. So here is the load. That is whatever appliance we want, that is connected here. So output will be between these 2 terminals. Here will be the output voltage. This is input voltage. Output is DC. That's why symbol we are giving like this. Input, if for AC generally small e, for EMF we require, we give that symbol. Okay, so these are the 2 diodes. Now this is the neutral wire of the center tap transformer. So suppose this is 0. If this is 24 plus 24, at that time what will be? This will come at plus 12. If you have taken 24 volt output, or if you have taken 12 volt only, then here 0, then here will be 6, here will be 12. Reverse, minus 12, minus 6, 0. It will remain always at 0. Now what is happening? For the positive half cycle, this will be 0, this is 12. This, for this example, what is happening to this diode? For this diode, what is happening? This is at 24 volt and this is at 12 volt. Both are positive only. Is the diode forward biased or reverse biased? Yes. Diode is forward biased. This is higher voltage 24, this is 12. So this is higher. So this diode is forward biased. Now come to this voltage, this diode. Here this is connected like this. So this is our plus 12. This side is 0. Now what is happening to this diode? 0 less than 12. So this diode is reverse biased. So when this diode is forward biased, this will be reverse biased. So when we are applying 24 volt, potential difference from here to here will be only 12 volt. This is at 12 volt. Suppose this starts conducting, then it will be also 24. So potential difference here 12 volt only. Less than that will be some resistance will be there. So less than that potential difference will be there. That will happen only in case of positive half cycle. It will vary. All are 0. Not a single will conduct. It will keep on 0, 1, 2. This will conduct. 0, 2, 4. Still forward biasing. 0, 12, 24. Forward biasing this one only. So it will keep on increasing. Again it will start decreasing. Then here also voltage will keep on decreasing. Now in the negative half cycle, what will be? Suppose this is coming at minus 24. This is minus 12. This is still 0. Now what is happening? This is minus 24. This is minus 12. Naturally, this is higher. This is lower. So this will not conduct. Now, this is 0 and this is minus 12. So this is higher, this is lower. So this will start conducting. So when this will conduct, the direction of current is in this way. When this will conduct, the direction of current is this way. So through this load, current will flow in the same direction. Direction of current is not changing. Whether this diode is conducting or this diode is conducting, the direction of current in this load is same. So in this case, we are getting current throughout the time. In the previous one, what happened? For positive one half cycle we are getting, for next half cycle we are not getting. But here we are getting constant current. Not constant, there is fluctuation, because variation is 0 to maximum, maximum to 0, 0 to maximum, maximum to 0, but in one direction only. In order to minimize this fluctuation, this circuit is also not used. We are using bridge circuit, but that is also not in our syllabus, so we are not going to see that one. So only this part. Again, the graph for this. Any confusion, anyone?
Sir,
Yeah.
sir, that upward when it is minus 24 volt, then it will be minus 12 volt. So at that time, what will happen?
What will happen? You say? Which one is lower?
So minus 24.
Minus 24. This is P type. So P type is having less voltage. So it is reversed bias. If P is connected to the negative terminal or the lower voltage, N is at higher potential, then it is reversed bias. In case of reverse bias, the diode will not conduct. So this diode will conduct for positive half cycle. This diode will conduct for negative half cycle of this output voltage of the transformer. Yes, any other confusion? When this is minus 20, 24, minus 12 and 0. So this is higher. 0 is higher than minus 12. So now this diode is forward bias, this diode is reverse bias. So this will not conduct, this will start conducting. But current passing through this load will be same direction. Direction will not change. Now the graph same way it will be. Okay, so just we'll mark and with pencil and then we'll remove it. So this is our input voltage. Versus time graph. This is output. Versus time graph. So this is output, this is input, plus E naught minus E naught. This will be whatever voltage you have decided you want to show, okay, no problem. So what will come? This will come like this. So it will be same distance will be. Okay. So this graph like this. So for positive half cycle, the upper diode will conduct. For negative half cycle, lower diode will conduct. Again, for a positive half cycle, upper diode will conduct. D1, if you name like that, this is D1 is conducting, this is D2 is conducting. D2 means lower one. D1 upper one, then D2 is conducting, then this is D1 is conducting. Okay, so this is full wave and half wave rectifier.